So, hello everyone, and welcome to our KRIS podcast, Breaking Down Stereotypes. Today I'm joined by Axel, one of our data solutions consultants, who is here to talk to us about data solution models. So first of all, hello Axel.
Hi Catherine, thank you for having me today.
No worries. Here we have a quote, "All models are wrong." Is this true? And if so, why do we keep using data science models?
To answer this question, I would refer not to mathematics, but to literature. In one of Douglas Adams' short stories, an enormous supercomputer is trained to find the answer to the ultimate question of life, the universe, and everything. In case you were wondering, the answer would be 42. Often forgotten, the following lines of the book are even more interesting in our case. It says, quote, "Deep Thoughts, the name of the supercomputer, points out that the answer seems meaningless because the beings who instructed it never knew what the question was. When asked to produce the ultimate question, Deep Thought says that it cannot. However, it can help to design an even more powerful computer that can." I just love that, because when you hear your model is wrong or useless, it could be due, in fact, to an issue to be resolved upstream, which has often not been sufficiently defined. Or sometimes it has changed in the meantime. And on top of that, if your model is hardly explainable, it can add even more confusion. And most of the time, we hope that by simply adding more computing power, we might get better results. So the main idea I want to convey through this podcast is that understanding a model and its field of application is even more important than spending hours optimizing the parameters in the hope of gaining a few % of accuracy.
And in practice, however, then, in your daily job, how are they explained?
Well, sometimes before we dive into technical details, we need to clarify what the chosen model is, and perhaps even more, what it is not. There's a large part of mathematics which consists of describing the world around us as best as possible, but based on purely theoretical equations. A striking example is the complex number I, we learned it in high school, that is created out of thin air. It has no value. However, this number is at the core of the equations that rule electronic engineering. With smartphones and computers that surround us, I guess that is in practice for us all. This is precisely what we don't do with our models. Most machine learning models are based on statistics. They are trained on past events, which we know well, because we have observed, recorded, measured, categorized, or labeled them. Then they reproduce the patterns on new data, because we assume that they will continue to repeat themselves in the future. They can be, for example, effective for time series that contain a trend, seasonality, or to identify anomalies. But can this be applied to establish forecasts for all industries under all circumstances? I guess not.
So how does Data IQ enable your teams to make their projects more comprehensible then?
Whatever the use case, Data IQ provides us with a visual interface that will allow users to display, in addition to the scores of their algorithm, many analysis axes on the elements that have influenced the performance. The project managers who decide whether or not to put the models into production are not necessarily developers, but they have a clear understanding of the end customer's needs. So more than performance, they require a strong understanding of how the chosen model works, the variable that matters the most, the possible biases, etc. All this is available without having to code it yourself in a unified interface. What I have observed is that in the end, it's not necessarily the best performing algorithm that are selected, but sometimes the simplest and most transparent.
And even with a very comprehensible model, efficiency remains key. So what happens after the models are deployed?
Once a model goes into production, way beyond the code, many monitoring features are added. They can be data quality checks, result recordings, over time, processing times, etc. The Data IQ labs stores our different trained models, And it can be configured to periodically retrain the models with new data, then put our models in competition, and to alert us if a previously less performing model outperforms the current one. That's why you could hear at the start of the pandemic that model failed with success, as they faced an unknown and unexpected situation. They call it black swan in finance. Most of them had to be retrained, taking this into consideration. These processes, they are commonly known as MLOps and data drift monitoring.
Okay, excellent. And if you had just say one thing as a conclusion?
Well, as a conclusion, I hope that I've convinced you that data science is not without conscience. And I would therefore like to conclude with a last quote from a famous British statistician, George Box. All models are wrong, but some are useful. Thank you.